As this is the first section, we'll just be starting with a basic intro into functions. So we'll first talk about what exactly functions are and how they're useful to us. Then we'll take a look at how to write some functions to perform tasks, and then how to call on those functions to execute the code written within them. As we generally approach these topics from a complete beginner's perspective, we assume that you know nothing about functions, and for those of you who are slightly more experienced, who know a lot about functions already, feel free to watch these videos at kind of 1.5 or 2 times speed. Otherwise, we'll jump right into our discussion on what exactly functions are. Well, we can think about a function as being a way to store a statement or a block of statements in a convenient place within our code to be executed only when we call upon that function. So what this means for us is that we can store code and kind of hide it away from the rest of the program, and that means that code won't be executed unless we actually call on the function by name, pass in any parameters, and thus invoke the actual execution of the function. Now this is really nice, really useful to us, because then this means that not every single line of code is executed every single time. It allows us fine control over when and where we want to actually execute certain blocks of code. Also, it provides a really nice way to organize our code into convenient blocks rather than just having everything all in one big chunk. Now this just generally makes debugging easier, and also just makes our code much more reader friendly. Now generally speaking, it's better practice to write several smaller functions that will each perform 1 or 2 small tasks, and then at the end we can kind of chain these functions together and call on them to execute an entire big task. So this is better practice than just writing one big function that performs several different tasks all at once. Not only does this once again improve code readability, but also makes it much easier to debug, because then we can find certain links within the chain that are really the problem links. Now we're going to explore function syntax mostly, just kind of get used to the concept of creating and using functions, and look at some very simple examples, but as we go we'll be getting more and more complex. As for function syntax, there are, I guess, 4 parts to the function. There's first of all the name of the function. Now this is typically an action word or action words, because a function is performing some kind of an action. Functions are really how we represent behavior within our code. So we reserve action words for these functions, whereas stuff like classes, objects, and variables and stuff like that, those are all typically nouns. As with most of the typical code naming conventions, we're going to be using camel case for our function names also. Now the second part would be the parameters that are passed into a function. So parameters are basically variable or constant values that are passed into the function once we call upon it, and then these are used throughout the function body to aid in the function's task. A function can have 0 parameters, or it can have as many parameters as we want. We'll start pretty basic at first with no parameters, and then we'll start adding parameters as we get more and more advanced. The third part to a function would be the return type. Now not all functions have return types, in fact many do not, in which case we simply specify a void return type or leave the return type blank. So what the return type is basically once the function finishes executing or reaches a return statement, it will basically spit out a value. So think about some kind of like an addition function. It might take in a couple of numbers as parameters, and then it might add them together in the function body, and the function body itself is the 4th part, by the way. That's the actual core of the function where all of the functionality is implemented. So our add function, again, take in a couple of numbers, actually add them together in the function body, and then it might return the result of the summation. So that result would be the return value. Okay, so those are your 4 main parts. I could just write them in a quick note. We have the name, we have parameters, we have return type, and then we have the function body, so the body. Okay, I think we'll start just by exploring some very basic functions in this section. Then in the next section we can introduce the concepts of parameters, then talk about return type, and then start talking about some more specific things we can do with functions. So the easiest way to learn this stuff is to actually do it, so let's launch right into an example. Now I'm going to keep using this video game example because I think it's quite relatable. And we are, for this section, going to go back to our movement example. So we have a character within our video game. He or she can kind of move around based on button or key press. User presses the right key. We increase the position. User presses the left key. We decrease the position. Now we've been representing this with just a player position and then increasing by 1 each time. We've done this with if statements. We've done this with while loops and stuff like that. So now we're going to put everything within a function because that's where things should actually be placed. So that's where all this behavior should be implemented. So what this will allow us to do is ignore any kind of movement commands until the user presses the right or the left key, rather than just moving our character regardless of what happens. So let's start with something very simple. And here, let me zoom out for you guys. I'm just going to create a variable first called player position. So this is going to be changing according to which button is pressed. And we'll just start this at 0. We've seen this variable lots of times before. So all we're going to do is increase or decrease the position, again, according to which button was pressed. So we'll put the functionality within a function rather than just saying something like player position plus equals 1, because this would be executed every single time. We'll have something like this. So we'll start with a func. This tells a compiler we're dealing with a function. We'll give this guy a name. Let's just say something like move player for now. Okay, we open and close a parentheses, so this is where parameters would go if we had any. If we had a return type, we would specify it like this, so like an int or a string return type or something else. However, we don't have anything, any return type or no return value, so we're just going to leave that blank. And then we simply open and close our curly braces and the function body goes in here. So again, name, parameters, return type would go here if there was one, and then the function body within here. So because this is quite a simple function, all we want to do is increase our player position by 1. So we could just say player position plus equals 1. Now note, once the playground finishes running, that nothing is changing here. So player position actually still equals 0. And if we printed it out down here, we know that it would still be 0. The reason being that although we've actually written the code to move the player, we are not executing this code, so there's no way of actually running this function right now until we call upon it. So this is just called the function implementation, where we write the code that the function would run once it's called upon. Okay, so it's not being called right now, but if it was, then it would execute this statement. And it would execute any other code which we put between these curly braces. Now if we do want to call on our function, we simply do it by name, so move player, and then enter in any parameter values we want. Before we do, I just want to note, it clearly says there are no parameters here, which is correct. And you see this void to the left of our move player function name. So this just means that it's not returning any value. Typically, if you see a value to the left of something like this copy file underscore move, for example, returns an int32, this is the return type. So this is going to be either what it expects to take in or what it expects to output. So if we just call move player, again, open and close a parentheses but nothing in it, this is a function call. Okay, so we can only call on a function that already exists, and it's a good thing move player does. So now we notice that player position equals 1 up here. And this is because we've successfully called upon move player. It's gone to the function declaration and implementation. It said, okay, well, within our body, all we're doing is increasing player position by 1, so let's do that. And now we know that we have spat out the result that the player position is going to be increased by 1. Okay, so hopefully you can start to see the benefit of putting our code within functions, because now I can choose to call upon my move player function only perhaps when the right key is pressed. If this was just out in the open, this would be called upon every single time regardless of what was happening. So even if our player was supposed to be standing still, he or she would actually be moving about unless we put this code in a function and only call upon it when appropriate. Right, so our function is moving our player forwards by 1, but there will be points in time when we need to move the player backwards. So the user presses the left key, we want to decrease our position by 1. So there's a few different ways we could do this. In the interest of keeping things simple, let's just explore the most mundane approach, and this is going to be to create another function that's just going to be move player backwards. So I'm going to rename this move player actually to move player forwards. Okay, move player forwards. We have to, of course, change the call to our function. And we'll create another function called move player backwards. Okay, again, no parameters, keeping things simple. We're just going to say player position minus equals 1. Okay, so now when move player backwards is called, it's going to decrease our player position by 1. So if we were to call it after this one, move player backwards, in exactly the same manner, then we would just return our player position to 0 because we've moved forwards by 1, but then moved right backwards by 1 as well. Okay, so that's not exactly what we want to do, because once again, we're just calling on the functions every time without any kind of input. What we would have ideally is some kind of button input or some way to detect when the user presses the right or left keys. Now, most often this is done with listener functions, which are basically which are often attached to key presses. So listener functions are functions that kind of listen for events. So this could be like a key press, this could be like a press down on a touch screen or something like that. And then once some event occurs, once a button is pressed or whatever, then it will send some kind of a trigger. And this will activate the functions. This is going to be a call to the function, and then within that function body we can put whatever code we'd want. So in this case we could like mimic a listener function for the right button key, which would call upon our move player forwards function when pressed or activated. Similarly, if the user presses the left button, we would trigger some kind of a listener for the left button, which would call our move player backwards. Now, I'm not going to simulate the trigger functions or the listener functions. I'm just going to go ahead and pretend that we have this variable that is just going to be the button pressed. Okay. And we're just going to set this to be a string that will represent the right button pressed, okay? So let's just pretend that if the left or right button was pressed, it would change our variable's value, and then we would call one of our move player functions. But we don't necessarily know which one, so why don't we write a function to determine which of these to call, okay? So what we can do is write something like this. We could have a function, and this one is just going to be called move player. Okay, again, we'll not take in any parameters for now. We'll see later on that it would probably be a little more appropriate to actually enter parameters in, but again, one step at a time. So now what we're going to do is test to see what value button press takes on, and call move player forwards or backwards accordingly. So we can do this with a simple if-else statement. Something like this might be appropriate. So if button pressed equals right, then we can call on our move player forwards. Okay, and then we could do like an else if button pressed equals left. We can move player backwards. All right, and maybe we should write an else clause, which is just going to print out maybe invalid command. Okay, so as of right now, our function move player is again just going to test to see which button is pressed. Is it the right button, or is it the left button, or is it something else? Okay, so if it's a right button, we're simply calling on our move player forward, so we'll increase player position by 1. And if the button pressed is left, we'll move player backwards, which would decrease it by 1. So now what we can do is just call move player. Let's just comment these guys out. And simply call upon move player, which would take care of the checking and all the work for us. So now if we were to print out player position, we would get the player position equal to 1. Because our button pressed is right, we're calling on our move player function, which goes up to here. It says, okay, what value is button press taking on? It's right, so let's move our player forwards, which then calls this function, which then increases our player position by 1. So this is what I mean by functional chaining, in which we have a function which calls another function which performs a task. In this particular case, these functions are called helper functions because although I could put this code right in here instead of the call to the other function, I'm choosing to put that small task within another smaller function and then just call upon that. Okay, so these would be called helper functions. Also, on a side note, while we're talking about function names and types, we'll often hear this word method being tossed around. So in object-oriented programming, methods are basically functions that are attached to classes or objects. So for the most part, functions don't exist outside of classes or objects in object-oriented programming, but if they did, they would be referred to as just regular functions. Within classes, they're referred to as methods, but for the most part, we'll be using these words interchangeably. So if you hear either method or function, they'll probably be referring to the same thing unless I state otherwise. Also, I might as well talk briefly about a function type, because this is kind of an important concept. So we know that variable names and class names and stuff like this, they all have to be unique. So we couldn't have a variable I of type int equal to 5, and we couldn't have a variable I, even of a different type string, equal to high. Okay, we couldn't have these two variables with the same name. Well, we can actually have functions with the same name just as long as they have different types. Okay. So a function's type is determined by its name, its parameters, and its return type. As long as any combination of those three factors is not the same as any other function, then we're perfectly fine. Okay? So for example, we could have a move player that has no parameters, and then we could also have a function move player that takes in an int I variable. Actually, this should be just I as an int, and this is just parameter syntax. I'll talk about that a little later. Okay, and this is perfectly acceptable. So we actually have two functions called movePlayer, but because this one has a different type than this one, that's allowed. Now again, the type is determined by name, parameter, and return type. So in the case of our movePlayer function, its type is the name, no parameters, no return type. In this case, our movePlayer function is of the type name, and it has one parameter, which is an int, and then again, no return type. So we'll probably be revisiting this concept a little more once we learn more about parameters and return types, because then this whole thing will become a little more clear. Now, before I end this first intro section and move on to parameter discussion, you might be looking at this code and saying, well, this is all very simple. I mean, why do we even need these helper functions in the first place? Why don't we just put player position plus equals 1 right in here? Well, you're absolutely right. There is a pretty optimal and easy solution. I mostly did this to demonstrate a point, but we would definitely really want these helper functions if there are multiple tasks being performed. As I said earlier, it's much better to have many smaller functions that all group together to perform one big task, rather than one massive function that does everything within its function body. And this is mostly just to make code intent a little clearer. Again, if there are multiple tasks being performed or multiple lines of code performing a single task, then we do want to put these in a single helper function with an appropriate name, so that anyone who's reading the code can simply look at the function and say, okay, well, this is moving the player forwards. I know exactly what the function does. I don't even have to look at the actual function implementation to understand this. Whereas if I had a few lines of code here, maybe it was moving the player, maybe it was printing something, maybe it was performing some check, I don't want to put that all in here, because then the reader would have to go through all of that and try and figure out exactly what's going on. Okay, so you'll very often see situations like this in which there'll be just a function performing just one very small simple task. You might say, well, that's pointless, and you're not wrong, but it's mostly just to communicate intent to anyone who's reading the code. Okay, otherwise I think we can just about end this section here, which was just our basic intro. Again, 4 parts to a function: the name, which is some kind of an action word usually, or words; the parameters, which will go within the brackets. That's what we're going to be exploring in the next section. The return type we'll explore after parameters. It's just be a value that is kind of returned or spat out at the end of the function execution, and the body, which contains the function code itself. We implement functions kind of like this, where we have func, the name, parameters, return type if anything, and then the body within the curly braces, and we call upon functions simply by name and by passing in any parameters in the brackets. Alright, so let's be right back and let's talk about some parameters.